In this video, we are going to talk about linear inequalities. So previously we had been talking about how to solve linear equations. So an inequality is a statement involving less than, greater than, less than or equal to, or greater than or equal to. All right, so here is an example of a linear inequality. You can see this looks a lot like the equations that we were solving before. And the main difference is that instead of an equal sign right here, we have, in this case, one of the inequality signs, in this case, greater than or equal to. Okay, so that's the main difference as far as an equation and an inequality. And so just like before, what we want to do is to solve these linear inequalities. And it's really, for linear inequalities, it's really pretty similar to what we were doing before. Now, once you get away from linear inequalities, then it's more complicated. But for right now, we are just sticking with linear inequalities, okay? And so all of the steps that we went through when we were solving linear inequalities, simplifying both sides, the addition principle, the multiplication principle, all of that sort of remains the same. And the one big exception is that whenever you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality sign. So that is the main difference between solving a linear equation and a linear inequality in terms of what you need to be careful about. Generally speaking, there's going to be a lot more solutions to the linear inequalities than with the linear equations, and so writing your answer will also be more complicated. But we will talk about that in a subsequent video. Okay, so for right now, the big thing that you need to focus on is whenever you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality sign. Okay. All right, so let's take a look at our first example. And it says solve the inequalities and then graph the solutions on the number line. All right, so all right, let's see, let's make sure that that's correct. Yep, that looks right. And so now I want to solve this linear inequality. And so the first thing that you want to do, just like with equations, is to simplify both sides as much as possible. So looking at the left-hand side over here, I can see that I have this 2 times the 1 minus x in parentheses. So I can use the distributive property, right, to distribute that 2 through the parentheses. Okay, so 2 times 1 is 2. 2 times minus 1x is minus 2x. And then the sign, greater than or equal to. And then 5x here. Okay. All right, so far so good. And now looking at each side is as simple as I can get it. 2 minus 2x, these can't be combined any further because they are not like terms, right? This term has the x in it, whereas this term doesn't. Over here on the 5x side, that's as simple as that can get, okay? All right, so next up then what I want to do is to use the addition principle, and I want to start adding and subtracting the same quantity to both sides of the inequality, right, with the goal of getting every term with an x on one side and every term without an x on the other side. So one thing that you could do is add 2x to both sides, and that would be the faster thing to do actually in this problem. But just to kind of illustrate that point about multiplying and dividing both sides by a negative number, I am not going to take the quickest route here. What I'm going to do is subtract 5x from both sides. All right, and when I do that over on this side, I'm going to have 2, and then minus 2x minus 5x is going to be minus 7x. And then over on the right side, I have 5x minus 5x. That's going to be 0. Okay. So I have every term with an x on one side. And then what I need to do is to get every term without the x on the other side. All right. And so what I'm going to do then is to subtract 2 from both sides. like so. All right, and then over here 2 minus 2 is 0, which I'm not going to bother to write. And then the minus 7x. Or run this right-hand side, 0 minus 2 is negative 2. Okay? All right, and so then I have every term with an x on one side, every term without the x on the other side, and that's what I want. So now finally I am going to use the multiplication principle that says you can divide both sides by any number you like except for 0. And remember, my goal is to get the x by itself on one side, just like it is with the equations. So in order to do that, I would have to divide both sides by a negative 7. Okay, and then here is where that one difference kicks in. Whenever you multiply or divide both sides by a negative number, then you have to flip the inequality sign. So down here, I have negative 7 divided by negative 7. That's a positive 1 times x, which I'm just going to write as x. And then because I divided both sides by a negative 7, I have to flip the inequality sign. All right, and over here, 2 divided by 7, or negative 2 divided by negative 7 comes out to be 2/7. All right. And so here I can see that I have x by itself on one side. So any number that's less than or equal to 2/7 is going to be a solution to this linear inequality. Okay. And then what you want to do is to graph these out. Okay. So to graph out this solution, what you would do is make a number line. Like so. Okay. And then I'm going to take this number that I get over here and put it on the number line, just kind of right in the middle. Like so. All right. And then I am going to shade one side of the number line. Okay. And so in this case, the x is going to be less than 2/7, right? And so if you're less than a number on the number line, that means you're over to the left. All right. So all the solutions over here on the number line are to the left. So I'm going to shade that in. Okay. And notice if I shade it in like this, that's going to tell me that all the solutions are over here to the left side of 2/7. Okay. And the thing is if say you erased all this work that we did and somebody just saw this graph right here, okay, it would be pretty clear that all of the solutions are over here on the left side of 2/7, right? But if somebody didn't see this work and they just looked at this, it would be really hard to tell whether or not you meant to include the 2/7 as a solution or not. Okay. Now for us, if we see this part, right, this part down here, x is less than or equal to 2/7, right, it's really easy to tell that we mean to include 2/7, right? Because if I take and I plug 2/7 into that inequality, right, with the less than or equal to, I get 2/7 is less than or equal to 2/7. That is true, right? And so that tells us that 2/7 is a solution of this inequality, and so is a solution of the original one as well. But just looking at the graph, right, it's really hard to tell. So what we're going to do is for these endpoints here where it's really hard to tell, like this 2/7 right here, we're either going to mark that 2/7 with a filled dot that looks like this or an open dot that looks like this. Okay. And so what we would do is if the number is a solution, right, then we would mark it with the filled dot. And so that's what we would do in this case. And normally what that corresponds to is when you have a less than or equal to or greater than or equal to. If the number is not a solution, then we would mark it with this open dot right here. All right. And that generally happens for these linear inequalities when it is a less than or greater than. Now, that's an oversimplification. It does get more complicated than that for other types of inequalities, right? But for these inequalities that we're looking at, that's a rough guide by what to go by. You have the inequality right here, so you can check to see whether or not is a solution or not a solution by plugging that number straight in, okay? And then you just have to tell whether it's true or false, okay? In this case, we know that it's true, right? So we know that 2/7 is a solution, right? So what we would do is to mark that 2/7 by a dot like so, a filled dot. All right, and now if somebody came along later and all they saw was this graph, then they would know 100% that 2/7 is a solution. All right, so it's really hard to tell when those numbers are on the end, or at the very edge, the boundary of your solution set, just by looking at the graph. It's easy to tell by looking here. So what you're going to have to do is you're going to have to mark these endpoints with either a filled dot like this if it is a solution, or an open dot if it's not a solution. Like I said, for linear inequalities, right, that kind of look like this, generally speaking, less than or equal to or greater than or equal to is going to get the filled dot. Less than or greater than is going to get an open dot. That's not true for more complicated situations, but I will let you know about that when we get to that point. Okay. All right, so here's the solution. This is in the inequality notation, and here is the graph, right, of the solution. In the next video, we will talk about interval notation, and then we will we'll do some examples.